Hello students, this is second video for assignment 7.0 and in this video we'll talk about three terms: resistance, reactance and impedance. I am sure all of you know the meaning of the term resistance. In one of the chapters, current electricity, we did deal with this component. Suppose if you have a 5-volt battery and if you have 1 ampere current passing through the circuit, you can find out value of this component resistor. So we know that with Ohm's law V is equal to IR. So R is equal to V by I, and then R is 5 by 1, so R is 5 ohm, right? Now what is significance of this number? Significance is that if this value is more, the loss of energy in this circuit is more. So the electrical energy supplied by this source, 5-volt source, is being converted. The electrical energy is being converted into heat energy. And then with Joule's law, you can find out how much is the heat loss also. But that is not point of interest right now, so we will not be going into very much detail. The essential part right now is that this component is resistance. What it does, it controls the current. If resistance is more, you will have difficulty increasing current. Okay, if you want high current, you will have to give more voltage. But our resistor is a component which obeys Ohm's law. This is Ohm's law. V is equal to IR is Ohm's law, where more the voltage, more the current you have. What if I have other type of source, the same R, but I connect it with a source which is changing its polarity, alternating source, it is called alternating voltage or alternating current, where it's not necessary, unlike this case where this is plus, this is minus. In case of alternating source, it is not necessary that A is positive, B is negative, always. For some time A is positive, B is negative, then in next half cycle A will be negative, B is positive. Okay, so here if I'm asked what is R, role of R remains same there too. Okay, because it is ohmic component, it obeys Ohm's law. So what is R? Resistance. What it does, it hinders current, okay, or it controls current. Now, what about capacitor and inductor? What if I have a circuit where I have capacitor connected with a battery? What if I have a circuit where capacitor is connected to AC source? When you say AC source, the equation is like Vm cos omega t, or it can be Vm sin omega t. Okay, alternating voltage can be represented as function of sine or cos. It can be changing its polarity like this, or it can be changing its polarity like this. Okay, both way it is possible, but both are sinusoidal function. So that is alternating voltage. It keeps on changing its polarity, and that is what we are talking about right now. Now in this case, as you have DC source connected, in short while one plate of the capacitor will be positively charged, and you will see that the other one is negatively charged, but then current will not flow. So is there any current in this circuit? Yes, momentary current you will find uh, which charges the capacitor, but once it is charged, then V is equal to Q by C equation is applicable. No more current you will have, and so there is no question of finding current. Now what happens in this case? In this case, the source is supplying energy, source is giving voltage, but we don't find proportionate current in this circuit. Why? Because this component is not wasting energy, but it is storing energy, and that is how it affects current. So in this case what is the effect of this component? Effect is more the value of the resistor less the current. It controls current by wasting energy, whereas in this case this component is also controlling current, but in some other way. Okay, so instead of using term resistance, the term used here is called reactance. Reactance is a term which is denoted by X, and more the X, more is the current controlling capacity. For capacitor, it is XC. If it is inductor, it is XL. And who decides how much is XC? So XC is given as 1 by omega C. How much is the value of the capacitor and how much is omega? I'm sure you remember omega. Omega is 2 pi f. So more the frequency of the alternating source generator, more is the omega, and then xc will be less. Okay, the source will sweep its polarity very fast, and then omega is increased, and then xc will be less. So this is called reactance of this capacitor. Similarly, if you consider a circuit with inductor, suppose if you have coil connected with a battery, nothing will happen. Okay, you will have current just like in this circuit where you have a resistor connected. Okay, so coil is not playing any role if you connect it with DC, but if you have AC source connected with an inductor, then AC is changing its polarity, direction and value of current is changed, and then inductor will be storing and supplying energy to the circuit, and then it is controlling the current. So there is reactance corresponding to the coil also. It is denoted as XL and it is given as omega L. So what is reactance? Reactance is a parameter which controls current in AC circuits. Reactance is not applicable for DC circuit. If you have this kind of battery connected, you don't have to worry about reactance. Reactance comes into picture only when you have alternating source connected to capacitor or inductor or both. But the role of reactance is very similar to that of resistance, and dimensionally also, if you see, unit of R is ohm, unit of XL or XC is also ohm. So they are same dimensionally, and hence suppose if you have some circuit where you have resistor, capacitor and inductor, all the three connected with alternating source, then in such circuit how do you find out the obstruction to current with this voltage source is trying to produce? Then the term used is called impedance, which is taking care of R as well as XC as well as XL. Okay, so impedance is like resistance only for AC circuits, which is having all the three or any two components of R, L, and C. And what is unit of impedance? Z. Sorry, unit of impedance is ohm. Conventional symbol is Z. Okay, and we'll talk about this impedance, its value, and how to deal with it in numericals later on during the uh, detailed derivation in the chapter. Okay, for now, what is resistance? A component which controls current in both AC and DC circuit. What is reactance? Reactance is a parameter which again influences the current, but in AC circuits only. Who can offer reactance? Capacitor and inductor. What is the capacitive reactance? Capacitive reactance is Xc. It is 1 by omega C. Inductive reactance is XL. It is omega L. What is impedance? Impedance is the combined effect of resistance and capacitance and inductance. So that is all we need to know about these three terms for now. Uh, we'll discuss it at greater length later on. Thank you.